So my name is Ryan Christiani. I'm the head instructor and development lead at HackerU. How many people have heard of HackerU before? Yes, sweet. R Christiani on Twitter. I'll just give you a second to follow. Not a lot of people on their phones. That's cool. RyanChristiani.com. Let's learn ES6.com. How many people have seen this before? I think one or two people. Okay, thank you. Is there a Node School Ottawa by any chance? No? Well. So I'm also an organizer for Node School Toronto. How many people have heard of the Node School movement before? A couple people. So nodeschool.io is like this free kind of community open source thing. And groups will get together in different cities and stuff like that and organize just a free meetup. You come and you work on Node. It's basically just a JavaScript meetup where you can get some mentors to help you work on some JavaScript stuff. So definitely check that out if you're ever in Toronto. Or I highly suggest maybe some of you getting together and making an Ottawa version because it's like a lot of fun. Let's Learn ES6. Let's Learn ES6 is a little book video series I started in January of last year, actually. And how many people have been contacted by a publisher where they're like, hey, do you want to publish a book? And you're like, no. And then you're like, I'll just do an ebook instead. I don't know if I goofed it or not, but I definitely went the ebook trail. So if you use this code here on letslearnes6.com, you can save 50%. I also do these videos, Let's Code Along, on YouTube. Made this really fun intro with a friend of mine. And when I say I mean he made the whole thing. I just kind of give him some money for it. So really, really fun. So what are we going to talk about today? So I want to talk about what a design pattern is. I want to explore some common patterns we'll be using, or you'll probably see a lot in JavaScript. I want to talk about PubSub, so publish, subscribe, Flux and Redux, and sort of how there's some similarities there, and how kind of understanding the underlying design pattern can help you actually understand more and more things as you go forward. So what is a design pattern? How many people have heard of or know much about design patterns? A couple people. So a design pattern is a reusable solution to a common problem. So each pattern describes a problem which occurs over and over again in our environment, and then describes a core solution to that problem in such a way that we could use the solution a million times over without ever doing the same thing twice. This is a quote by a man named Christopher Alexander, and he's actually an architect. So in the 60s, Christopher Alexander did a lot of work in pattern language movement, mostly for architecture. As you can imagine, buildings like this, there's a lot of common patterns you see over and over and over again, right? And a lot of people started to take this idea and actually implement it into software design and programming language design. As I was saying, it's not actually a super new pattern or a new concept. It's been around since the 60s. I think it was the 70s when people started to implement it in software design and into programming language design itself. So it's not super, super new. The real key here is that patterns help us identify problems and pick appropriate solutions. So it allows us to select from a catalog of trusted abstractions, trusted solutions, trusted patterns to do certain things. My favorite is this one. So for instance, in Alexander's work, bus stops and waiting rooms, like in a hospital or a surgery center or something like that, they're exactly the same thing, right? They're a place to wait, but they are completely different in their application. But they follow a similar pattern, right? That was from the great historian Wikipedia. In about 1994, 1995, this book was released. It's called The Gang of Four book. Does anybody have this book? Cool. So this book is referred to as the Gang of Four book. If you ever hear somebody say that, that's what they mean. They're just talking about this book here. Basically, a book written by 4 authors who sort of wanted to outline all of these patterns into a printed copy, a printed version of something for us to look at. And they break these patterns up into 3 sort of types. So there's a creational kind of type of pattern. There's lots of them. But these are stuff like factory patterns, so like factory functions, stuff like that. Singleton pattern, for example. Structural patterns, so a facade pattern. So I love to think of jQuery. jQuery is a huge facade, right? You kind of use add class, and it's I'm going to do a bazillion other things, but here's the facade. You get to use this nice little thing here. And a decorator pattern. We're going to look at one today, a behavioral pattern, observer pattern. More importantly, we'll look at a really simple implementation of that, the publish subscribe pattern. How many people know C++ and Smalltalk, though? Okay, 1, 2, a couple people, a couple more hands coming up as we went. If you don't know these languages, these patterns in this book might be harder to reason about. There's a lot of great content around how they work, but when you start looking at the code, you're like, So there's a really great book to kind of like use as a companion to this. Adi Osmani did JavaScript design patterns, and I highly suggest you pick this one up. Cool, so patterns are everywhere. For example, MVC pattern, right? Pretty hot button topic, let's say 3-5 years ago in the JavaScript scene. Maybe not so much anymore. We're more like the V and MVC these days, or the Vue and MVC, Vue.js. But for example, the MVC pattern is a pattern, but it is also made up of many other patterns. The way that these portions of the model of the view and the controller actually communicate together, there's a lot of other patterns in there. So we're going to be looking at the publish subscribe pattern today. And realistically, learning these patterns helps us dissect larger patterns. So we can reason about more easily a very large pattern if we can understand sort of like the fine workings inside. Let's look at some patterns that you probably use in JavaScript that maybe you weren't aware that was actually what you were doing was using a pattern. So how many people have written some code like this where they use a single object to sort of contain their application? Nobody, a couple people. So this is a fairly common pattern when you're really getting started with JavaScript, right? You're not using modules yet. You're not like having these huge build tools. You're just kind of working with like a little application that you're just getting started with. There's actually a really great talk by a man named Alex McPherson. He used to work at like Clear Left or something like that from Colorado, where he kind of breaks down like your evolution as a JavaScript developer, where you have no code, no JavaScript, and then you're like, oh, I'll use like jQuery, and then you kind of like go into this pattern. I love that talk. I'll post it on Twitter later. But anyways, the namespacing pattern is a pattern where you have a single object and you kind of just add your properties and your methods to this object. So what it allows us to do is it allows us to contain our application in one space, and it allows us to prevent pollution of the global scope. So instead of us just kind of like putting all of our variables out there, all of our functions out there, we have one object that we're putting out there when we create our application, and that's what we can work with. It's a really simple pattern. It allows us to prevent name clashes. So if we have a variable and then somebody else has some third-party JavaScript and they didn't do a really good job of like containing their JavaScript, we aren't going to clash with our names. Prevents pollution of the global scope. And ultimately helps us kind of reason about spaghetti code. So our code isn't just everywhere on the page. We're like, this thing calls this thing. We can kind of like follow it a little bit better and see where it all lives together. Excuse me. There's also the module pattern. So really kind of popular pattern a couple of years ago to help us sort of create a sense of privacy and create kind of modules in our code before we even had the ability to do modules. So the idea is you have some sort of object that you want to return. So we have this function here, this immediately invoked function expression. And what it does is it will return an object that will act as our like public interface. Inside of it, we can make our function, make other function declarations, variable declarations, but they all live privately inside of here. I'll show you what that means here. So using the power of like closures and functions and objects, we can create some privacy. So age is a private variable inside of here. We can define an interface, this object called getAge, birthday, that actually allows us to set and get that private variable. But it allows us to kind of keep this private. So again, allows us to kind of create some privacy and allows us to define our interface that we want the user to interact with. Instead of just giving the user, and when I say user in this case, I mean other developers, the ability to just like change anything they want. So how do these patterns maybe help us manage state? So Pepe Sylvia, it's a really good episode. One really popular pattern is this publish subscribe pattern, or PubSub you'll hear it referred to most often. It's a variation on the observer pattern. It's a really simple implementation of it because the observer pattern has a lot more going on and I didn't want to get too involved into that. Basically, it's an object that has a subscribe and a publish method. And the idea is that you can publish an action or like an event, and you can subscribe to many actions or many events. So like, this code may or may not make any sense, but basically a method can take an event and can take some data to publish out to something. This listeners object is basically just a hash of callbacks that we've kind of registered up to be like, hey, if somebody, let's say, publishes an increase event, is there an increase event in the queue? If there is, is there an increase callback in the queue? If there is, go ahead and run through all of those and call all the functions for it and pass the data along so that other pieces of UI will get that information. Subscribe basically allows us to say, here's an event type, here's a callback function I'd like to register, so when this event happens, please let me get some data from that. This is the first of 3 very exciting demonstrations. Are you ready? It increased it by 1. So this is a really simple implementation. It's just like we have 2 buttons that increase and decrease. And it's actually really small, but up in the top corner here, there's a little click counter that's listening for both the increase and decrease values. I hope you really enjoyed that. There's 2 more of those to come. So hooking it up, how does this work? Well, we've introduced this PubSub object. We have a subscribe method that we can subscribe to an increase event here. And then I'm using an arrow function here to say, subscribe this callback function when the increase event is published. I want to get some data. And when we publish something, we can simply say PubSub, in our case here, PubSub.publish increase, and pass it some data. And that means that anything, any bit of our UI that's listening for that increase event is going to get some information. And that's sort of the initial underpinning of how we can kind of get this nice decoupled data from our views. And it allows us to register like our UI components to specific events, or maybe multiple events if we want. So I think it was like 2013 or something like that. Google introduced Flux. That sounds maybe too old. I don't know. Flux was introduced at Facebook, and it was introduced at Facebook to solve like a really common problem. And I'm sure you've actually probably seen this problem. When I post links, there's a video here that actually explains their original thinking about why they introduced Flux. But have you ever been on Facebook, and this was years ago, where it would have your messages, there'd be that little 1 there, or maybe 2 or 3, and like you'd be like, I've read the message, I've read it in all the 3 different places I can read it, but it would still be there? They had this issue of state in their application, huge application, right? It was not working for them at all. So they introduced this new pattern called Flux to sort of like help reason about large amounts of components listening to the same data set over and over again to make it a little bit easier to work with. One really important concept here, and this goes with Redux as well, is Flux is just a pattern. It is not specific to React. Facebook also created React, and they use it with React, but it is not specific to just doing it with React. You can use Flux with anything. It promotes a single directional data flow. So instead of kind of looping back all over the place, you kind of just keep passing data into like a circle, and I'll show you what that means in a second. So if we're thinking about the publish subscribe sort of method, this introduced 3 new things. And one of them is kind of the same as the other, as something else. So it introduced stores, actions, and dispatcher. But the dispatcher in this case is sort of like our publisher. So the idea is you dispatch actions to your stores. The stores will handle the data, and your components will listen to changes on those stores. So you now have this flow of, instead of publishing a thing, you dispatch something, and then the dispatcher is what actually sends the stuff along. So it looks like this. You have dispatcher, that stuff goes to the stores change the data, goes to your component, and then the component could dispatch another action, and you just kind of keep that flow going. So stores, this is kind of a great idea because with the PubSub before, we just kind of like, I don't know, what do we do with the data? We just kind of store it wherever we want. Introducing stores allows us to keep the data in a specific location, and allows us to work with the components because we can always just get data from those stores if we want. So with Flux, you actually have many, many stores. So for every sort of bit of data you want, you would create your own store for that. If we were at Shopify, I'd make a Shopify joke because you like make a Shopify store. It's okay. I do a lot of teaching. I like to try some new material. That was not a good one. So with stores, you do something like this. It's actually fairly common to use, because at this point we're all using Node to like build our stuff. Use like the event emitter. So you create a new store that extends the event emitter, because the event emitter allows us to actually like emit events. So like a change event, for example. In this case, we just set up a store, a counter store that literally has one state, this counter state. And this really helps us now decouple our data and centralize it in specific containers, specific stores. So we're starting to get away from this like crime wall situation CSI episode. So you can dispatch an action. Again, think publish an action. In this case, the dispatcher will do this. You tell it what type of action you want, and you can give it some data like a payload. None of these keys in this object, I should point out, are like required. When we get to Redux, like the type is required, but you could call this payload, data, anything that you really want there. You can subscribe to a store. So inside of your components, you can now subscribe to a store and listen for the change event. And what that means is that inside of our code somewhere, in this actions handler, whenever we actually dispatch an action, a change event is emitted. And anybody listening to that will actually get the data. So it might look something like this. And this is sort of also where Redux starts to get, it starts to look a little bit more like Redux, right? So when something is dispatched, we register what we want to handle that dispatch. It gets passed into this function. It's just common to use switch statements, I think, because people get really fussy about the if, else, else if stuff, and it looks a little bit cleaner. I do know that you don't need curly brackets there. I just like them. So your switch statement, you say what type of action has occurred here. In this case, if it's an increase, let's add to the counter. If it's a decrease, let's remove from the counter, and then we just keep going. Inside of those actual events there, though, we can actually handle these changes, handle these data changes, and then emit the change event. And as you saw earlier, anything that was like listening to that store on change would get that information. I know you're very excited. What do you like? I see the hand going. You're like, what's going to happen? You're like, what? Wow. Does the same thing. The key point here is it does the same thing. It's a different type of pattern, but it has the same underpinning, right? It allows us to do essentially exactly the same thing. All of our actions are passed to all of our stores. So if we had actually registered multiple stores, all of those stores would be getting all of those actions. So you can actually, with a single dispatch, maybe affect several different stores and have different parts of your UI update based on that if you want. Pretty cool. And breaking our data out into components really helps us decouple our system. This is a really interesting idea, sort of the principle of least knowledge. Basically, when you decouple your system, you kind of have things only talk to friends. So objects would only talk to their friends and not friends of friends. So you shouldn't go too deep, right? Because once you start to do that, you get a little bit like code smelly, and it's like a little bit harder to reason about your applications. OK, the big one, Redux. How many people feel like they have to learn Redux at some point in their lives? Probably everybody. I think everyone's hand should be up. Because I teach a lot of people and because I teach a lot of juniors, like after we kind of get through the boot camp, it's like, oh, now I have to learn Redux. I'm like, maybe you don't have to right now, but it's like when Angular was like the thing everyone had to learn right away. Where is Angular now? It's still around, actually. It's fine. So Redux, it takes ideas from Flux and introduces a few new things while changing some of these things along the way. So one key change is that instead of having many stores, we now have one store, so one state, one key source of truth, which is one of the principles of Redux. And we have what we now call reducers. And the reducers sort of act on the different parts of our state. So reducers take all of the actions, like the stores did in the Flux model, and they allow us to change the state as we go. It's now a simple object, this store, the store state, sorry. Man, there's still a lot of S's in there. The store's state is now a simple object that contains our data, and our reducers will be responsible for acting on specific parts of that object, specific parts of that store. No? Oh, it's okay. Very exciting. Again, I think the real key takeaway is I actually talked to some of my colleagues, and they're like, maybe you take those out because they're not really exciting. And I was like, I like them. But the idea is that this is a completely different pattern, in a sense, but it accomplishes the same goal, right? It allows us to, if I go back here, it allows us to like listen for events, actions on something, and update bits of UI. I know this is a little small up here, but like both of these things update when both of those things get clicked, right? You'll maybe appreciate it later. So a reducer in Redux looks a lot like that action handler from Flux. It takes, except now it accepts a state, so the previous state or an initial state, and it takes the action. And what happens is the actions go through, we use the switch statement again to sort of like decide what we want to do with our state, and then we alter the state. The really interesting thing here is that we don't actually mutate the state. Another principle of Redux is that you don't want to mutate your state. You want it to be read-only. So what we're doing here is, if it's a number in this sense, we're just adding to that number. That expression is evaluated and then it's returned from the case statement here. And then it just kind of keeps going. We create a store. Now we can use this create store, and we can add many reducers. So similar to how we registered our actions for our store as before, we now do it a little bit differently here. And look at this. So Redux stores come with 3 methods. Dispatch, think publish, subscribe, think subscribe, and getState. So think we didn't have a getState. But getState allows us to get the state of our data, right? So you dispatch an action similar to how we dispatch an action with Flux, except now the dispatch comes from the store itself, not a dispatcher. We can subscribe anything we want to the store for whenever any changes happen. And we can go ahead and use the getState method here to actually get the state and put it wherever we want. Now this is all using this outside of the context of React. If you're doing this inside of React, you'd probably have some sort of connects going on and container components and stuff like that. But if you're going to learn Redux, I highly suggest learn Redux in the context of just Redux. Don't learn Redux in the context of React, because when you do that, you have to include so many other things, so many other layers on top of it, that learning the underlying pattern is going to be really, really helpful. So one of the last things I kind of want to talk about is this idea in Redux is that everything should be sort of immutable, right? I mentioned before that we don't alter our state. What we do is we actually go ahead and we make a copy of it, or we return a new version of it. And this is a really, really nice idea, because this starts to promote this idea of function purity. And when we're starting to learn about these patterns, you can actually see that you're actually starting to learn about more concepts that maybe you didn't know about before. So a pure function is a function that has no side effects. So it doesn't alter the data passed to it. It actually goes ahead and returns a new version of that object. So if you're thinking an object, an array, it'll create a copy of that, return that new object, and then alter that thing. So a really quick example, an impure function would be something like this. Let total equal 0, function add, takes a and b, but we're altering total like right there. So that's altering, that's creating a side effect. The function has a side effect, right? A pure function would take 2 values and then return a new thing. That would be a pure function, right? Because now we know somewhere if we use total, total is not going to be changed. If I had total in this case and then I called add maybe 5 more times somewhere else, we would have no predictability on what total could potentially be. So with our reducers, what we do is, in this case, we're doing it with a number, but you'll commonly see it being done with objects, where you see like object.assign, or if you're using sort of more FutureJS object spread. But we're always taking the state as it is, cloning it, copying it, then mutating it, and then returning that new copy of it. So pure functions help us write more maintainable, predictable code. Yeah. So recap, basically my recap is this. Patterns are everywhere, and whenever you're trying to learn something super new like a Redux or like MobX and stuff like that, all these things that are coming out, RxJS, there's always an underlying concept, an underlying theory that these things are built off of. Very, very rarely is it ever like a brand new, groundbreaking idea. Learning these patterns, learning the history of these things will really help you understand and maybe help you actually just like completely grok a new library or a new set of tools. Thank you.